right, so tonight I'm going to talk about NOM. NOM is a library for making parsers in Rust. It's basically a huge collection of macros that can be combined in very useful ways that provide sort of a declarative DSL for talking about how you expect to match a string or a byte array. NOM is for eating data byte by byte, which is awesome. So we're going to look through a couple of example parsers tonight. Basically a hello world parser, and then something for looking at some of the information in PNG files. Then I'm going to talk about some troubleshooting with NOM. One of the disadvantages of having a crate that is basically, at least the public methods in it are basically all macros, is that you can get annoying compiler errors that are difficult to understand. So I'm going to talk about a couple of compiler errors I've gotten, how I resolved them, and then I'm going to talk about a side project I've been working on that uses NOM, and we might, if there's time, live code and make some changes to it. So this is our very first NOM parser. It matches the string cargo with the C optionally capitalized. So what this does is it gives us a function that takes in a byte array and or a byte slice and returns an I result, which is sort of NOM's main type that is either done, incomplete, or error. NOM introduces itself as a parser combinator, and the combinator comes from the fact that there are lots of things that combine parsers, right? So there are macros that take another NOM parser and give you yet another NOM parser. For example, alt takes any number of type-separated parsers and makes a new parser that is happy if any of its constituent parsers are happy. So it's very, very easy to combine fairly complicated parsers out of very simple things in NOM, which I think is its greatest strength. So here's just an example match statement over the NOM I result. So this is a match from the result on the previous slide. So you'll either get done, which has input, that's the rest of the input, and the output, which is by default the piece of bytes that matched the parsers, but also output can be a user-defined type, which is super handy. Or it can be an error. An error happens if it knows that it can't match. For example, if the first byte wasn't either an upper or lowercase ASCII C, then the previous parser would return an error. And incomplete will say, I need at least this many bytes, but I didn't get it all. So that's a second type of failed parsing. And because basically all the NOM macros make a function that returns a I result, you can chain them together. For example, alt, the way this works, when it expands, it's going to try the first tag, and then in the match statement on the first tag, in the error case, it's just going to try the second tag. And so it expands to actually a fairly straightforward and efficient function that can check whether the bytes passed in match these things. Another nice feature of NOM is that it doesn't copy the input array at all. It just keeps track of slices, which is really handy. So you can not copy things. All right, so this is a parser for the header of a PNG file. So we can sort of see that we have this declarative, like this is what the beginning bytes of a PNG file look like. So we have a PNG signature, which is just a literal byte array that I have that has to match. All PNGs start with this like 8 bytes. It includes the ASCII for PNG and a bunch of white space characters to make sure that the file process didn't strip out like line endings or swap line endings. And then all chunks of PNG files have lengths and types, which are both 4 bytes. The length is, but we're ignoring those in this case. So I'm just doing take 4, which is a very simple parser. It matches any 4 bytes. It's happy unless the input is too short. Then for the width, we're going to get an integer out of it. And for the height, we're going to get an integer out of it. And then color type is another parser that I'm calling. It will pull the color type from the color type byte. filter method and the innerlace method. And this returns a PNG header struct, which is a struct I defined for this example that looks just like that. So I think you'll agree that this is significantly more readable and less error prone than trying to for loop over a bunch of bytes or keep track of indexes or something. And it's particularly handy to have just like, hey, the next 4 bytes happen to be an integer. I know that. Just give me the integer. So here's how color type works. So color type's an enum I defined. It's a single byte in the PNG file, but it's really, there's only like 7 legal values for it. So I decided to define it as an enum. So the byte 0 happens to be grayscale. So there's several more of those. And then the color type is just any of those. So if any of those are happy, then the result of the whole value will be a num iResult done with the output being whatever color type was matched and the rest field being the rest of the byte array. So it can just keep going. And so you can have this like user-defined parser in here. And if any of these fail, the whole thing will fail. And so you can just match on the return of this and say, hey, is this a valid PNG file? If so, great. Here's a struct that represents its header. It's very, very simple to call this. So the combined parser will fail if any of its constituents fail. And yeah, I think we already went through all this. So it also makes, as far as I've seen, it only ever makes safe rust, which is great. So let's combine this into parsing even more of the PNG. So PNG file, there's more to it after this. So we're stopping before we get to the actual compressed data stream of the picture, parsing out like the metadata at the beginning of the file. So we have the header, we already looked at that. And then we have the palette, which is basically an array of red, green, blue triples that you can store colors in the PNG file as indexes into that array instead of storing them as literal triples. So that's an optional piece of the PNG file. It might be completely absent. It's allowed to be present and 0 items long. It's also allowed to be present and have like repeat entries or something. So I guess you could make arbitrarily large PNG files with redundant palette entries if you really wanted to for some reason. So this parses that much of the PNG file. So there's a couple, I guess we could call them higher order nom macros in here. Right? So we have many 0, which takes a parser that matches a thing and gives you a new parser that matches a vector of that thing. So RGB triple takes a byte slice and gives me one instance of the RGB triple. Many 0 gives me a vector of RGB triples, and many 0 matches at 0 or more of them. Or there's also many 1, and there's also many MN. Many MN has a minimum and maximum length that it can match. And so here's for a more complete PNG file parse. The PNG header, we have CRC at the end of the header, which I'm just sort of ignoring here. I didn't write the actual validation for it. We could, Nom has a macro called error code, which you could put in a parser to just say, hey, I failed on purpose. So we could, instead of this like take 4, we could check that the CRC is actually what we expect it to be. And then palette has the higher macro opt, which takes a parser that returns whatever and gives you a new parser that either returns an option of that. So it will either return a vector of these triples, or it will do nothing and be happy and just pass on the input unchanged. So if it can't match for some reason, it won't like fail the parse, it will just return none and keep going. So it's really handy to have things like that. and keep you from having to write a weird function that goes from like a byte slice to an option of a vector of this particular struct. Like that would get sort of annoying pretty soon, but by having like opt many R2B triple, then we're done. We get what we're looking for. So that's the example parser I wanted to show. The main drawback of working in NOM is weird compiler errors. You'll get an error like no rules expected to token I underscore, which is not super helpful. I didn't name anything I underscore, and I don't know what that's about. Well, I do, I'll tell you in a second. Does anybody see what's wrong with lines 64 through 66 here? I'm going to tell you in a second. But just take a look to kind of get the error in your head. So I'll give you a hint. I'm missing a pair of parentheses. Not that they're unbalanced, I'm missing the whole pair. So, okay. Yeah, exactly. So color type should be, if you need to parenthesize the results of do parse, even if it's a single thing. So that's the change that gets rid of that error. Things like that, I found a little bit by documentation and a little bit by experimenting, but I have found really commonly, specifically like no macro rules expected I underscore means the thing before that was missing some parentheses. So that's a pretty common thing. And missing, if you're returning a single value, at least I find I don't really like instinctively parenthesize that single value, but because of the way these expand when you string them together, you have to parenthesize the return value, even if it's just like, even if you're just returning like one int or something. Why this particular error? So non-parsers expand to functions like this at the beginning. So if you don't close the previous parser, then the next parser is going to put the beginning of itself before that one is closed. And so NUM will think that I underscore is supposed to be part of the previous expansion, and will just fail. So that's why you get that particular error. I was really curious, so I dumped out a bunch of expanded NUM stuff and read it. It's not that bad. It's basically a whole bunch of match statements with like the different parsers branching out in the error case of the previous parser, or in the done case if you're matching stuff sequentially. The other thing I do to try to get myself out of trouble is experiment with simpler parsers. So for a while, I had something wrong in this parser. I think I misunderstood the docs, and I thought I didn't have to pass endianness if I thought that was okay, but I do. It was giving me some kind of weird error. So basically, I just experimented with simplifying the parser until the error went away and then adding things back in. When I was first working with NUM, I had to do that quite a few times. So I mentioned it as something that's specifically helpful. So those are sort of my two tricks, are like simplify, try to get the smallest case that produces the error, and also put parentheses around things, especially around return values. And then one thing that I found really helpful that Rusty does is Rusty will actually suggest macro names now, which I think is really cool. I thought that was sort of above and beyond in a compiler error. But like, this looked right to me at first. I forget that there were many 0 and many 1, sort of like star and plus regular expressions. But Rusty helpfully said, hey, there is a macro you could use that's almost the same string, which I thought was really great. Yeah.
So you had do parse in the last slide. Is this a I'm sure like a standard library? It was on the previous.
Do parse is a So do parse is a NOM macro that basically lets you. Let me go back to where I have the like non-commented normal looking one. This will do. So do parse gives you the ability to say, hey, I have variable thing that's going to give me that variable. And then I guess these are like supposed to look like pipes or something, right? Those are just part of the macro. So you could say like header meet is the result of this PNG header parser, and then header CRC is the result of take 4, and then palette is the result of palette chunk, and then that all goes into a PNG file. So that doParse is the non-macro that lets you return user-defined types out of. Basically, these all go together, and then at the end, in parentheses, you get an expression where you have access to all these variables, and you can put together a struct or do. Right? You can put any code in there you want, but so that's how you return user-defined types out of that.
Each of those steps is executed in order, right?
Yeah, yeah. So you can do like, I've done stuff like _ take 4, good, just to skip 4 bytes in the file, which will fail if there aren't 4 bytes left. But other than that, take will match any array. And then named is also a non-macro that gives you a parser. There's a couple different syntaxes for it. I kind of like this one because it looks so much like a function declaration. I think it's pretty easy to read. So this is going to make me a function in this scope called PNG file that takes a byte slice and returns a nom-I result that wraps a PNG file, or incomplete or error, which are like non-internal things. So, any other questions about this? This is sure.
So during parsing, say if you have a file that partway down after you've done the identifier, you have 2 bytes that if it's 0, then the next section is just blank. But if it's got a number, then that's for every one of those, there's going to be extra data. So if you have a conditional parsing for your file.
Kind of. I think I left that out of the slides, but let me see. Yeah, so this macro, you see I have length, which is in the file, right? Take 4 bytes and make it a DU of 32. And then I'm doing this, many MN. So this will fail unless there are exactly length RGB triples, right? So I have access to length, not just down in these parentheses, but like in the other macros, I can use it as inputs to functions in there or whatever. There are also macros like take while and take until, which you can pass it a function that it will call, and it will like stop consuming bytes when the function becomes true or becomes false. So yeah, and you can do like little in-place literal tags, which is sort of cool, right? Like PLT is just like the ASCII bytes for that are just in the PNG file to say like, hey, this is the beginning of the palette vector. So does that answer your question well?
Yeah.
Cool. Okay. So now for the side project I wanted to show you all. So this is a very simple scheme-like calculator language that I wrote that basically tokenizes input with nom and then shift reduce parsers to evaluate. And so I thought a fun way of experimenting with nom a little bit tonight would be to make up an operator over its rules and add it to this language. So this is basically the language right now. So you can have tokens, which are left parens, right parens, operators, or types. The operations are pretty straightforward, with greater than and less than and want to type. So they're GT and LT. And then for types right now, we just have rules and integers. And then for the tokenizer, there's a lot of very, very simple functions like this, right? So if we get a tag that's literally the byte for an ASCII right paren, then that matches the right paren. There's a whole lot of those. I guess the downside is they're kind of repetitive, but the upside is they're super easy to get right. So that's a plus. And then this is where I thought really shined is like, this is basically the tokenizer for the language. So a single token is one of my other tokens, and then WS is a macro that basically lets the macros inside it be white space separated. So that means like when we're matching single tokens, we're gonna skip white space between single tokens because we don't care about it. And then, so we just basically like, our program is an array of 0 or more tokens, which is one of these things. And I can just call this and then unwrap the results or match on the result. And then I have the stream of tokens for this language. And I didn't have to write like loops or anything, which I thought was really cool. And then I was thinking we could add an operator to this language. Does anybody have any good ideas for an operator?
Running operator.
Probably not. Does anybody have any easier ideas for an operator?
Can we add an interface?
I don't know how that works, but me, okay.
Yes. Yes.
So we can't be wrong about how to add it. What's that? We have to use Unicode somehow. I mean, Nom will already do Unicode. I don't know. I'm sure we could add a tag that matches on Unicode, right? We could probably, it might be a pain to test, but we could definitely write an operator that matches on some particular Unicode character.
Do you have a much better, more straightforward?
I mean, I was thinking we could do like a min or a max, right? Those are pretty straightforward examples.
like modulo.
Yeah, I mean,
Okay.
modulo might be weird because they all operate on like lists. So I'm not sure what modulo would do if you gave it like 5 operands or something. So
Right.
what's that?
You can loop, right? Or lists.
Um,
Go back over it again.
yeah, I suppose.
That'll do modulo.
So what will we do? We take like the first pair and like mod it, and then mod that with the next pair, and then
Take your
okay. We can try that. So
yeah.
what's that?
No, I was no, go ahead.
Okay.
Sorry.
Cool. So let's try to do that. So this is the part where this well-prepared talk is probably going to fall apart, but should be fun. So we're going to add a mod operator. We'll get some compiler errors now because there's some unhappy match statements. So let's do name bang modulo. So this is the other syntax for declaring named. So this is the same thing, right? This is the same thing as if I wrote like right. So those are just alternate syntaxes. Nom supports either of them. I only knew about this one when I was writing this file. Kind of like the other one better now, but we'll be consistent. So let's do alt tag. Let's do either the keyword mod or %. Oh, and we need like a. So right now this probably won't work because it has the wrong type signature, right? Because alt is just going to give me the bytes that matched one of those two. So we need to do parse.
Exclamation point.
Yep. Okay. Okay, cool. So now let's add that to here. Okay, so that was like all the nom we had to do. Now this language will match that kind of token, which is pretty cool. Let's get some compiler errors, find where my other match statements are. I don't know why I bothered implementing format for this. It does exactly the same thing that debug would do. I just thought I was going to want to print things out differently. And then here, we'll have to actually write code. So I'll code mod. Let's do, that sounds like an integer reducer. Cool. So basically, the reducer here, what we're doing is we're looping over these tokens until we get to a right paren, and then we're trying to simplify the array of tokens we've already seen by passing them through one of these reducers, and then we push that back onto the array of tokens we've already received. So when we get to a right paren, we resolve that expression and then put it back. So you can nest expressions arbitrarily that way, which is kind of fun. So now that function doesn't exist, so, oh, come on, there's totally integer reducers. Well, so that's a helper that just says, hey, these are all that's really not.
Is it if they're not all integers?
It just returns error. So there are some places in this where I panic, where I really should like return some sensible error, but okay, so that's where we'll actually write. Sorry? Yeah, I don't need that. You're right. Thank you. Another thing I would like to add someday is some sense of like what went wrong, but right now we just return an empty error. Cool. So. Let's see. I guess initial. This is really going to be a lot like the reduced division, I would think. Well, that's not what I wanted. We can probably, for demonstration purposes, try this and just see how far we got. Is that basically what people were thinking of, right? So I'm going to fold this by saying, hey, right? So I take the first item I care about, modulo it with the next one, take whatever the result of that is, modulo it with the next one. I don't know how interesting this calculation will be, but okay, cool. So let's see this blow up. Sure. So let's try like mod 3.2. Okay, so far so good. Let's try, see if the parser does what we think it does. Trying to think of something that would be interesting, like 7, and then 4. Probably what's going to happen is something got reversed,
Like that's the most common bug I've had in this, is that something is backwards from like pushing onto a stack and then iterating it, folding it. So let's do like this. I don't even know what that should be. That's probably, should that be 0? Yeah. Okay, so it's probably running through things backwards.
Wait, if we're going totally backwards, that would be 3, right? Yeah. If we're in 3 mod 4, that'd be 3, and 3 mod 7 is 3.
3 mod 7 is 1, right?
No, it's 4 mod 3 and then 7 mod 1.
Oh, there, yeah, that makes sense.
7 mod 1.
Yeah. Okay, so it is totally backwards.
Let's do the last 2 did mod and then roll that.
Yeah, and did mod. So we
So
should.
if you put a parenthesis around 4 3, it'd be correct.
Or we call it interrobang.
We can define whatever. I'll just put a comment. Modulus means interrobang in this language, and then yeah, cool. Yeah. So I think I could probably I could just reverse this, right? But I'm not sure if you all want to watch me like debug this strange language I wrote. So let's go back to talking about DOM. And yeah, does anybody have any questions about how this is working? This is where the tokens come from, right? I just say, hey, so I'm parsing it. I get a vector of tokens, or I get a tokenization error. So I'm going to get the tokens. If I'm done and there are no bytes left, then we're okay. We have a vector of tokens. Otherwise, I'm unhappy because in this language, I have the rule that if there's just like stuff I don't recognize at the end of your input, that's invalid because I don't know what that was. So I had to add that. Like normally, Nom is perfectly happy to just finish and give you back the rest of the byte slice that it didn't match on. So I have explicit code that decides that's an error case. Yeah, so that's about all I had. Any specific questions or anything? Yes.
Yes. So if when you have all the successful like tokens, is it also preserve? Or is it possible to preserve like let you know what position they were in the source string?
I haven't tried to do that. That's something that I would probably try to do if I start trying to figure out how to show like sensible error messages here. So I don't know where, yeah, I don't know whether Nom is keeping track of that at all. So I can look into that, but I don't know the answer. Sure.
So the errors are
Yeah.
you know what that is? Is that like some text or?
So the Nom iResult is actually, I had that somewhere in here. So it's just an enum, and it's like the only type defined in Rust. So
Could you
sure, sorry. So basically, it's an result that has input and output, or it has the error. So basically, the input is what's left, the output is what you matched, and the error code is, well, I did not need to click on U32, we know what that is. And the error code is like different, Nom uses that to represent different things like, this was an alternative macro and none of the branches were satisfied, or this was a, integer and there weren't enough bytes left. Or, well, that would be an incomplete, but it has different errors. So let's see.
Are you familiar with like in Rust? Okay. Yeah. So this is like a tagged union. Let's see.
Right. So these are the three choices for an iResult. It's either done with input and output, I think input is sort of confusingly named there. That's actually the rest of the input. Like it's a slice with the bytes we didn't match yet. And then the output, or it's an error, or it's incomplete, and it just tells you like, hey, I needed 6 bytes. There weren't 6 bytes. So those are basically the 3 things it can do. And then by chaining together basically NOM is just chaining together. Like this is what the expansion of the parsers I've been showing tonight looks like. So we're just saying, hey, try to compare these arrays. If we succeed, great. If we don't, go into the other branch.
And so so like whether it can tell you how many bytes it needs depends on how explicit the macro is and what it takes.
Right. So all the macros by default all take a slice of bytes. You can also make them take a stir or a.
But I mean, like with the tag, right? You're saying, okay, I take 3 bytes, and you only provide 2, so I can tell you I needed another byte. But like if you have a more complicated function, right? If you don't necessarily, right? There was a line 1960.
Right.
It doesn't necessarily. It can't just magically always know how much it needs to complete it. It's only because the parser it's binding happens to be one that is explicit about the size of the thing and so.
Well, I think that the parsers, except for parsers that like expand like many or something, I think they're pretty explicit about the size. So a lot of times when one of the ways that we'll get unknown here is if it has an integer overflow when it's trying to figure out how many bytes it still needs, it will return unknown. So it's keeping track of that. You see a lot of like little blocks like this. Just looking through here, but I don't know whether it's keeping track of. It must be keeping track of the index a little bit because it just gets a slice and then it knows where. But I think it just makes another slice, right? So to pass on to the next input, it's the slice, right? This is the macro that matches tag 0, right? This would be like color scale gray. So it's going to give you a slice of what's left and a slice of what matched by default in the done. So I guess the next one has a slice of what's left, but I don't think it knows how many bytes were before that slice. So I think you would have to add something to keep track of like where in the array you stopped matching. Yeah.
How do you see the generated parser? Is there like
yeah, there is. Let me see. It's like cargo rust C Z, like something like expanded macro pretty or something. And then I typed it. It's like that. You can look it up. That's not quite right.
It's also in, I think,
yeah, it is. Actually, that's a good point. My slide with the error message will. Yeah. Oh no, that's external macro backtrace, which I think is different. I'm not sure. I think that'll show you an error message in the expanded. So, right, so this is showing you the line where the compiler error happened in your own source code. If you pass this, it will show you the line where the error happened in the expanded macro. But there's also a way of telling Cargo, like, hey, in this crate, dump all the expanded macros and everything into one file, which is how I got this file. And it looks basically like this, but I can't remember. I wonder if it'll just like.
there's also that option.
Yeah, well, I'm going to see that. I'm just going to run this, and then it's going to not unknown debugging option.
I don't think that would be a dash. It's an argument to dash Z, right? It wouldn't have its own dash.
Okay. I should have typed to a different file because now I overwrote my thing.
What is your patch history?
Probably somewhere, but this is probably faster. That seems reasonable. Let's try that. Oh, wow. Okay, that needs to be piped somewhere. There we go. Expected this file to get longer after I did that. Anyway, so yeah, there we go. It just didn't reload. So that's how you do that. And it makes kind of huge files, but it's also kind of nice to see though that it's like not magic, right? It's basically just a huge match statement with like recursively adding more match statements in the different branches as appropriate and taking slices that are further into this byte array as appropriate. So eventually it'll just return whatever it does.
You had a couple of examples. Do you want to go through share the link to that now, or like?
Oh, sure.
Like, because you have the repo, right? With like the cargo example. And then
yeah. I don't think I. Come on. Yeah. So we have. Yeah, let me put up those links. I can like email them to you or something, or like
make a comment
in the meetup with. Yeah. So these slides are in repo. They're just like remark.js slides, and then also they like this repo with the PNG expansions is here. So you can see we got the this is like. I have this PNG file, which is actually a screenshot of the parser, which is great. You can see it's getting like sensible information out of it. So this is just kind of a little example. And you can see what it like cargo, it gets done, and the output is the ASCII bytes that match cargo for car. It's incomplete, needed size 5. For some other string, it's error alt, right? Alt that wasn't happy with any of its subparsers. So yeah, I will put links to the repo with the slides and the repo with the example programs in the meetup notes. Okay. Cool. Yeah, so I guess that's it. So Will Murphy is taken on like all media ever. There's literally like an NFL player and a bishop with the same name as me, so I can't get my username on anything. So I use Will Murphy's code for GitHub, Gmail. And then for sources, I use the PNG format spec and the non box. So thank you.